Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 6 of Devsecops Zero to Hero series, and in this episode we will focus on SAST, SCA and DAST, three pillars of application security. And most importantly in today's video, we will learn these concepts practically. And you don't have to worry, after watching today's video, if you want to practice the concepts, you can head to my GitHub repository, Devsecops Zero to Hero. Head to the day 6 folder for today's video, where you will find a README file. And within the README file, I've created everything that you need. So it covers the theory part and also it has all the demos that I'm going to perform in the video. Perfect. So without wasting any time, let's start with the video. First of all, what is application security and why is it important? To understand this better, let's look at a simple application development lifecycle. Now, a very basic application development lifecycle. So there are three important phases. Number one is the dev phase, where developers work on writing the source code of the application. And they also test the application locally. Then comes the test phase, where QA engineers, they rerun the unit test cases just to verify the unit tests are passing. And they also run something called as regression testing or functional testing. Very simple. Let's take e-commerce application as example, as we all use e-commerce on day-to-day basis. What happens in regression testing? The QA engineers verify if the complete user flow is working as expected and all the features of application are working together well, or there are any issues. For example, a user is able to log in, user is able to look for the product, search a product, then add the product to the catalog, perform the payment, and get the application shipped there to their location. So this is what the QA engineers verify in the regression testing or functional testing. And finally, if everything looks good, QA engineers do the go ahead so that application is shipped to production. As I told you, this is a very basic application development lifecycle. Now on paper or at a very high level, this actually looks good because application is tested locally by the developers. Then QA engineers also performed unit testing. At their end, they performed regression testing. They verified application features are working fine. And only then application is moved to production. But if you see in this entire workflow, security of the application is not taken into consideration. Now, developer might have taken security into consideration while writing the application, but who knows? There is a possibility that developer might have overseen some use cases or developer might have ignored certain security considerations. In this entire application development lifecycle, the security testing is not performed, which is actually very important because now application might work well for the end users, but a bad actor can actually attack the application and maybe gain the access to the database, gain the access to the user's information in the database, and even maybe bring your application down in the production. What not? Because the security testing of the application is not performed. This is where application security or Appsec comes into picture. And Appsec is one of the most important pieces of Devsecops lifecycle. So what a good Devsecops engineer does, along with the regular workflow, a good Devsecops engineer brings application security tools or concepts like SAST, SCA, and DAST into the organization. If the organization already has a CI/CD pipeline, to the existing CI/CD pipeline, a Devsecops engineer introduce these tools and concepts. But Abhishek, in our case, our QA engineers also perform penetration testing. They perform different types of testings like performance testing as well. But still, that does not comes under security testing of the application. As QA engineers, they might use some tools for penetration testing. They might use tools for performance testing, but those tools are not designed for the security testing of the application. Now, what is security testing? Okay, I have been saying the application should be tested from security point of view, but what are some common use cases? I'll give you very simple use cases so that you understand them well. As simple as, what if one of the developers hasn't taken care of SSL certificates well? One of the developers, while writing the application, has used some insecure certificates, right? Or maybe disabled security verification of the SSL in the application code so that security is skipped and application can easily talk to the other applications without considering security. Or maybe developer who is working on application hard-coded some secrets. The peer who is reviewing, another developer who is reviewing the code might have overlooked into it. And common cases like SQL injection. SQL injection is very difficult to detect at times. As a human, if you are reviewing other developers' code, you might skip SQL injection. You might not see it because hackers have their own ways of injecting things into your SQL queries and getting access to the databases. You definitely need some tools to verify if there is a possibility of SQL injection patterns. On top of that, there can be some insecure libraries, right? Very common thing. Maybe developer is using Flask and developer is using 1.2 version of the Flask. What if this version is vulnerable? Now, this version already has some critical vulnerabilities reported on the internet and your developer did not know about it. Even somebody is reviewing the code, they might not know about it. Definitely QA engineers will not be aware of this vulnerability with a particular version because there will be thousands of packages that developers use in their code, right? These are some cases, right? When we move forward in the video, you will learn about other cases as well, but these are some common cases. And if you're working with JavaScript applications, cases like CORS, right? Cases like CSRF. Again, these things are very difficult to figure out in the manual code review process. That's why security testing is important. Now, there are three important pieces. One is SAST, other is SCA, and finally DAST. How does these concepts help in the application security part? Let's go by one. First one, SAST. SAST is basically static application security testing. That means in the SAST testing, if you're using any tools, for example, SonarQube is a very popular tool in this space. So when Devsecops engineers use SonarQube and when they connect their application to the SonarQube, what SonarQube does, it goes through the source code of the application and it looks at the source code to understand, because it's a tool, it also comes with some AI capabilities. It has a database of known patterns. With all of those things, the tools like SonarQube can say if your application is potentially exposable to SQL injection. It can say if there is any insecure SSL verification used in the application, if there is any issues with weak cryptography, right? Or if your developer is using any insecure modules, it can be even as simple as an insecure YAML module, or maybe hard coding of secrets. All of this can be caught by the SonarQube. Now, this is a very interesting space. A lot of times interviewers ask you, okay, you used SonarQube, but what exactly are the common issues that you caught in the application using SonarQube, or the common cases that SonarQube helped your organization with? The reason why interviewers ask you this question, interviewers feel you might have learned SonarQube from some places, but you haven't implemented SonarQube in real time. Now, how do you tackle this situation? Don't worry. Because this is a common case, I've documented popular SonarQube cases in our MD file. So these are 10 popular SonarQube use cases that are used in the DevSecOps space. Hard coding secrets, SQLing injection, command execution risk, insecure deserialization, arbitrary code execution. You can go through them after watching the video. But what I'm trying to say here, SonarQube or static application security testing is a way where a tool can help the DevSecOps engineers go through the source code. It goes through the source code and it identifies any common patterns of insecure behavior in the application. Then comes SCA. Now, what is SCA? Very simple. SCA stands for Software Composition Analysis. As the name suggests, what exactly it does? It looks at dependencies of the application, right? It looks at what direct dependencies is the application using and indirect dependencies that the application is using. Very simple. You might be using Flask, but Flask internally might be using 100 dependencies. You might be using a particular version of the Flask. You feel you are using the right version, but even because Flask is using insecure dependency, your application will be indirectly exposed to the threat. So you should not only look at direct dependencies, but you should also see if any of your indirect dependency is potentially exposable to the security threat. But Abhishek, this is very difficult because I'm using a Python application. In the Python application, I'm already using 1000 dependencies. That means these 1000 dependencies, each of them might be using 100 dependencies internally. So it becomes 1000 times 100. So technically 100,000 dependencies in my application. I'm just making up this number. Usually it's not this huge. It might come around 1000 to 2000 dependencies. But yes, you have to ensure that direct dependencies and indirect dependencies are secure for your application. You cannot do it as a human. It's not possible. This is where SCA comes into picture. Software composition analysis, where every programming language has some tools. For example, in today's video, we will look at a Python application, which I intentionally I'm using old versions or deprecated versions in the application, and we will use a Python utility that can help us, that will show us the dependency issues in the application. Similarly, Golang, Java, every programming language has their own set of tools. Abhishek, can't SonarQube do it? It can do it to some extent, but it is always good if you rely on the SCA tools rather than relying on SAST tools for dependency tracking. Perfect. Finally, DAST. Very, very important. It's actually a simple concept, but it's important. What is DAST? Dynamic Application Security Testing. It actually does similar thing like SAST, but only thing is that DAST is about runtime. In SAST, a tool goes through the source code of your application and it looks at the common vulnerability patterns. But when it comes to DAST tools, they don't look at source code of your application. In fact, they don't need any source code of your application. What they do, They just need URL of your running application and they start performing different testing on the running application. So they make thousands of API calls to your application to verify if there are any known security issues with your application. Why is DAST very important? Because this is how hackers also work. What hackers usually do, let's say you have an application and your application is running on the internet. Now hackers do not have your application source code. They just take a browser and they start hitting your application for different patterns. If your application is an e-commerce application, they'll try from logging into the application, they'll go to one product, they go to the other product, they try to make API calls to your catalog service. They are not sure, right? Which part of your application is vulnerable? They are not sure because they don't have the source code. But they figure out that by making thousands of API calls. And they make those API calls on hundreds of websites. Even if one website, one flow of the one website is hackable, their job is done. They figured out one website and it's good for them. They can get ransom from those websites. The same way DAST tools also work. You can deploy a DAST tool in your organization. If your organization has 3 different websites, maybe internal, external, another external, give your DAST tool just the URL of all these tools, all these websites, and it will make hundred thousands of API calls and it will figure out, okay, in this application, there are 10 known patterns for the hackers. In this, there are 5 known patterns. In this, there are 4 known patterns. It's up to you. Do you want to fix it or not? But my job is to report the issues to you. And as I told you, in today's video, the DAST tutorial is going to be very interesting. I have a demo e-commerce application, a cool one, which is almost like a real e-commerce application. It has all the flows, including login, including payments, everything. So we will use that application and we will use a DAST tool to show you how the DAST tool can figure out the patterns. Perfect. I'll repeat one more time before I go to the demos. Very shortly, right? What is SAST? So we learned there are 3 pillars of application security testing: SAST, SCA, and DAST. What is SAST? SAST is nothing but static application software testing. That is, a SAST tool just goes through source code of your application. It identifies all the known patterns in your application. This is basically part of static code analysis. SAST is a sophisticated area or a particular area of static code analysis where tools perform static testing on the apps. And popular tool in this space is SonarQube. Then what is SCA? SCA is basically software composition analysis. In short, you can just call it as dependency checkers, because the tools in the space of SCA, they go through direct dependencies of your application, indirect dependencies of the application, and they verify if any particular version of your app, direct or indirect, is known to the hackers. Is potentially vulnerable in terms of CVEs. Finally, DAST. What is DAST? Dynamic application security testing. When it comes to DAST, this is performed during the runtime. So you can just give the tool. In our case, we will use OWASP Zap, a very popular open source free tool. Usually when it comes to DAST, most of the tools are paid tools, but we will go with OWASP Zap, a very popular open source and free tool. And using this tool, you can just provide URL and it starts sending thousands of API calls to identify any insecure patterns in your application, like the similar ones. Whatever we learned in SAST, almost the same things. It tells you if there is any CORS related issue in your application, if there is any CSRF issue in your application, or if you're using any insecure cryptographic modules or insecure SSL, almost the same things, but here it tells you through the runtime environment. Perfect. Now that this is clear, let's start with SAST first. So we will do the SAST demo now. What we will do? We will take a simple Python application. Okay. We will install SonarQube through Docker, and we will just connect the Python application to the SonarQube, and we will run Sonar CLI. To connect it, we will run the Sonar CLI in the place where we have the application source code. So Sonar CLI will talk to the SonarQube and send the information of the application source code. Let's do that. So first of all, we need the application. Don't worry, we will clone our Devsecops 0 to hero repository, because here I already have the application. App.py is our Python application. What is it doing? It's just a web application that is making API call to the database. That's it. Nothing more than that. A simple web app that makes a query to the database. Now, when you look at it, it actually looks good, because it returns user management service on the home page, and it is rightly connecting to the database. So to the naked eye, you cannot see any issues. It's generating a random token and it is connecting to the database. Let's see what SonarQube tells. So for that, I'll clone this repo. On my terminal, I'll move to the test folder. I have a test folder, and I'll just remove everything here and clone our Devsecops repository. Git clone followed by GitHub Veeramalla Devsecops 0 to hero. Perfect. Now this will clone the repository for us. Let's move to the repo. We have different folders. Let's move to 06 folder. And here we have the app.py, we have requirements.txt to run the application, and we have sonar projects.properties. But Abhishek, what is this? Once we install SonarQube, we have to create this file and we have to provide the URL of the SonarQube. Only then Sonar CLI understands where is the SonarQube application. First, let's install SonarQube. So for that, you need to have Docker running. We will run SonarQube as a container. If you have Docker running, just run this command, docker run -d, basically a detachable container running in the background. We are using the port 9000 because SonarQube runs on the port 9000 inside the container, and we are exposing it 9000 on our local host as well. If on your machine 9000 is already in use, just change the first 9000 here, because this represents the host port. You can just change it to 9001, 9002, up to you. Name of the container, I'm calling it as SonarQube container. Again, you can change it, but do not change the image. This is important. We are using a SonarQube image 9.9 community version. That is, we are using free version of the SonarQube. Abhishek, what is the difference between free version of the SonarQube and paid version of the SonarQube? Just like any tool, with the free version, you can track only certain patterns. End of the day, what SonarQube is doing, it is performing static testing. It will return only for certain patterns if you are going with the community edition. But if you are using enterprise version, then it's more powerful. It can go through your application more in detail, especially the source code, and it can recognize more patterns that are not part of the community edition. So for your practice, use the community edition. Tomorrow, if you're joining a company and if you want to recommend a company the SAST tool, recommend them SonarQube Enterprise. Perfect. Cool. Now, let's verify if SonarQube is running. So we will take the local host followed by port 9000. There you go. SonarQube is running for us. All systems are operational. Home. What is the username and password? For the default version, if you just install SonarQube, the username is admin and password is also admin. See how simple it is. For community edition, you just have to run a Docker command and everything is done for you. Okay, let's change the password. Old password is admin. New password, you can set up anything. Just make sure you remember it. There you go. Okay, now we have SonarQube running here. The beauty of SonarQube is that you can connect your application on your local machine, or you can integrate it with your CI/CD as well, which we will see in the next video. In today's video, let's only learn these tools. Let's not focus on CI/CD. Anyways, so you can connect with any of your Git distributions like GitHub, Bitbucket, anything. Or you can just connect your application manually to SonarQube, which we will do in the video. But Abhishek, how do I connect manually? If I want to connect through GitHub, I'll just provide my GitHub URL. I'll provide my GitHub API token. How do I do it manually? Of course, this is important because you will use something called as SonarQube CLI. So using SonarQube CLI, you will connect to the SonarQube interface. To install SonarQube CLI, you can just follow the steps in the official Sonar documentation. Reason why I am referring you to SonarQube CLI documentation, I can directly share you the command, but the versions keep changing. Let's say you're watching this video after 6 months. I'll put the commands in the GitHub documentation. You will try to follow it and it will break because as the versions keep changing, the parameters might change. So that's why I'm asking you to go to the Sonar CLI, the documentation. The link is in our MD file, the link to the website. Just scroll down. All you have to do here, just scroll down. You will find this hover. Click on the hover and you will find the download button. That's it. Just download it. Rest all steps you can follow from my documentation. Okay. So now once we are here, that is once we are with the SonarQube CLI, once you download it, prepare the Sonar properties. So wherever you have your application, in our case, we have application here, app.py. In the same location, prepare this file, sonarprojects.properties. And what you will put in this file? You can put the SonarQube URL. Either you can put it here or you can pass it through the CLI parameter. In my case, I'm just providing the values. What is the name of my project? This project name will be reflected in the SonarQube UI. Right now, there are no projects here, right? If I click on projects, there is nothing here. Once we run SonarQube, then a project will be created with the name vulnerable Python application. And I'm saying SonarQube that my programming language is Python. Even if you don't say that, it is intelligent enough to detect it, but it's a good practice to do it. Now, I already have Sonar CLI on my machine. So I'll run this command. Sonar scanner, right? Sonar scanner is the CLI. -d sonar host. There is my sonar host running on localhost port 9000. So I pass that. This is what I was talking about. You can even pass this in the sonar properties. Finally, I'm saying this is my sonar login token. Abhishek, what is the purpose of token? Without that, your Sonar CLI cannot connect to the Sonar UI. Who knows? You might be running this command. Someone else might be running this command. So for CLI to authenticate to the UI, you need the Sonar API token. Where will you get it? Simple. Just head to your settings here. Head to my account. Here you will find security. click on the security and just create a token. I'll call this as test token, global analysis token, and generate it. In real time, this is generated by the admins. Perfect. Now click on the enter and see the magic. SonarQube is reading your Python application and it will detect any issues with your application. Okay, it says unknown key, sonar.project key. Very simple. Actually, this should be sonar project.properties, not sonar projects.properties. I'll just change this from sonar projects.properties to sonar project.properties. And let's rerun the sonar CLI. I think I have to change this in the GitHub repository as well. I'll change it. There you go. Now you can see analysis is successful and analysis is pushed to the Sonar UI. Let's see if I click on the projects. There you go. So here, vulnerable Python application is verified by SonarQube. And what does it say? It says there are no bugs, there are no vulnerabilities, but in the hotspots reviewed, it is in the E status. That means it found out some issues with our application. There are 2 security hotspots. So it is saying you don't have any critical vulnerabilities in your application, but there are 2 security hotspots which you should take a look at. When we looked at the application, we did not find that. Like looking at app.py, everything looked good. But SonarQube said, no, there are 2 issues with your application. Let's see what is that. The first one, so it says there is cross-site request forgery, which is CSRF. If you are into application development, you understand it. If you're not into application development, I don't want to complicate the concept because CSRF itself is a very huge concept. Just understand that within this application, there is a risk that is figured out by SonarQube. Now, SonarQube does not only tell you the issue, but it also says what is the risk and to what extent you have the risk. Sometimes, because these are tools, they just look at the source code and they think your application might have the issue. But SonarQube is a step ahead. What it says, you are only exposed to this issue if you are using a web application that uses cookies to authenticate the users. In our case, we are not doing anything like that. It's a very simple Python application. And it says, if you're performing any sensitive web operations, if your application supports HTTP post request or HTTP delete request, only then your application is exposed to this security hotspot. Now, in my case, it is not. So what I can do, I can go back to the security hotspot. Now, I can click on this and I can in fact say this is not issue in my case, right? So I'll go here in the review. I'll change the status to safe. Scroll down. I'll mark the status. Continue review. Now you will notice if you go back to the security hotspot, you will only find one issue. 50% is reviewed and fixed. I'm just trying to show you how the issues are addressed within the organization. It's not that SonarQube identified an issue and okay, you will just say it identified the issue, then we'll just keep it in the SonarQube. No, in real time, these issues are taken into Jira. These issues are worked by the developers. And once developers are confident, they come back here, they mark the issues as done. Then there is another issue with the application, another security hotspot. It says you used random.random to generate a random token, which can be issue in real time. So what SonarQube is saying, you are generating a random token, but this is not a secure package. Hackers can easily figure out what is your random token. So SonarQube recommends go ahead and change it. Again, developers work on it. And if they feel it is secure, if they feel they changed it, then they rerun the SonarQube analysis. But for some reason, if they feel it is already safe, they mark it as safe and they close this issue as well. Perfect. So this is static analysis security testing. Okay. So now what did we learn? We learned for SAST, one of the popular tools is SonarQube. We learned how to run SonarQube. We learned it through Docker. But Abhishek, in real time also, can I run it using Docker? Yeah, definitely. If you plan to use community edition in your organization, just spin up a virtual machine for SonarQube, run SonarQube as a Docker container. There is no problem in it. Just that you have to connect it with a database so that you maintain the state of SonarQube. Or you can run it as a Kubernetes pod as well, and you make it stateful application. But in most of the cases, these days organizations go with enterprise SonarQube version. So they don't have to install SonarQube. They don't have to set up SonarQube. They'll just get the enterprise SonarQube. They will run the Sonar scanner where they will provide the URL of the enterprise SonarQube, which is a SaaS offering that is provided by SonarQube company themselves. Perfect. Now, let's look at SCA, right? What is SCA? As we learned, SCA is nothing but the composition analysis, software composition analysis. Let's do that on the same application. We are using a Python application, right? So for this Python application, there are two dependencies. If I cat the requirements.txt, in this case, developer said, I'm using Flask and I'm using the request module. And these are the versions I got from the internet. I'm using these versions. Now, as a Devsecops engineer, what you can do, you can perform SC on this application. How? First of all, create a virtual environment, Python 3 -m pip venv.venv. That is, create a virtual environment. Okay. Oh, my bad. Python 3 -m venv.venv. Next, once the virtual environment is created, source the virtual environment. Source.venv bin activate. Perfect. Now, instead of directly installing the application, which you usually do as DevOps engineer, this time install something called pip install pip audit. Now, for every programming language, as I told you, there are different utilities. For Python, which you most likely work with, the utility is pip audit. Now, using pip audit, because we installed, we can just run pip audit -r requirements.txt. See the magic. Pip audit not only goes through those two dependencies, but it will also go through indirect dependencies, and it will tell you, hey, these are the vulnerabilities in your dependencies. It also gave you the CVE numbers, which is very good. No? Giving the CVE numbers, it is very easy for you. Now you can create a Jira ticket saying that these are the packages that are vulnerable. And if they ask you why are they vulnerable, just you can tell them as DevOps engineers, I'm not sure. You can go to this CVE and read about it. Because you are using an outdated version, this is a CVE. Go through it, read it, and you will understand. What developers do? They just copy the CVE number, they go to the internet, and they paste it on the internet. Usually there are many sources, like there is National Vulnerability Database, that is very trusted one, the NVD, or they can go to Red Hat Vulnerability Database or the popular ones. Personally, I look at NVD most of the times because it provides up-to-date information. So developers go through, they read it. Oh, okay, this is why there is issue in my application. Let me go ahead and fix it. Cool. So we learned about SCA as well. Now let's move to the final one. SCA is very easy. That's why I'm not repeating it again. You just have to install a utility and you just have to run one command. Now let's move to DAST. What is DAST? So we learned that for DAST, we have to run the application and then we will use a tool called OWASP Zap. Right? If you remember, we used OWASP in episode 1 as well, where we learned about threat modeling. There we learned OWASP threat module, right? But here we used OWASP threat dragon there for modeling, threat modeling. Here we are using something called as OWASP Zap. These are just tools. Installing them is not a big deal. What you need to know is which tool to use in the right place. We need an application for this, right? To verify DAST, we have to do it at runtime. But which application are we going to use? The better the application, better is performance of DAST. Only then you will be able to explain the interviewer or even within your organization if you have to do a proof of concept. For DAST, you need a very good application. Only then there will be more vulnerabilities in the application. Where will you get that one? So here, let me introduce you to something called as OWASP Juice Shop. So basically, one of the open source developers, they built this Juice Shop application, which is basically a e-commerce juice selling platform. And intentionally, they wrote this application with a lot of vulnerabilities. Now, when you run this application, it creates an e-commerce platform. Let me show you. We should have it somewhere here. I'll open the application and just show you how the application looks like. So this is how the application looks like. So you can find different juices, just like how you find different products on an e-commerce platform. You can find different juices. You can read about a particular juice. You can read about customer reviews. And in fact, you can place orders as well. But for that, you have to first log into the platform. Again, just like a real e-commerce application. I'll just log into the platform. And once you log in, you can select a product. Now that goes to your basket. You can add multiple numbers of the same product. Click on the checkout. You can provide the address. In fact, after providing the address, you can also head to the checkout and provide your bank account details. Of course, you will provide dummy details, and you can head with the shipment part as well. Just to simulate a real world e-commerce platform, they developed this application. Good thing is this application is open source. So everyone started using this application for their demo purpose. Even I have used this application as a demo application in lot of presentations. Anyways, now we have an application. So we can use this application. Good thing is that this application is made intentionally vulnerable. Now what we will do, we will install OWASP Zap, right? We will install OWASP Zap on our local machine. We will run this application on our local host and connect OWASP Zap with this application. And rest, the Zap will take care. It will make API calls to this app and it will generate an HTML report for us. So we can go through the HTML report and we can verify. In fact, what it gave is right or wrong. Let's do that. First, I'll run this application locally. How do I do that? I'll first stop the container of this application. I already had it running. Let me just stop the container. So for that, I'll do all the containers. I've removed them. Now, this is the Docker command to run the container, the juice shop container. Docker run -d. I'm running it in the background. The name of the container is juice shop. I'm running it on port 3000. And again, I'm mapping it to 3000 on my local host. You can find this command from our MD file. Okay. Now on port 3000, I have the juice shop running. Next, we need the Zap container. For the Zap container also, just run this Docker command. Just like how we installed SonarQube using a Docker command, we can install OWASP Zap also through a Docker container. Cool. Because this is open source, we can do it. Okay, there seems to be a typo here. Let me just fix it. So if you notice the command, I'm asking it to create an HTML file, zap report.html. And if you observe carefully, I'm passing my application URL as well. So I'm saying Zap, my application is running on port 3000 and it is running as a Docker container. That's why I gave host.docker.internal 3000 port. Abhishek, is there a way where I can actually run OWASP Zap through the user interface? Because when I perform a proof of concept, it will be better if I show my organization through the user interface. Yeah, we will do that as well. For now, let's run Zap as a container. Let's get the HTML file because this is the easiest way. Then in the next step, I'll show you how you can run this through the user interface as well and how you can connect your application with the Zap. Container is installed. Now it is actually using the automation framework. What does that mean? It started making API requests to our JuShop application. It started making hundreds, thousands of API requests. So it will take time. And you can see here. In fact, see, it made some API request. That's why it said access a confidential document. So something is happening behind what we see. Zap is making API requests to our JuShop application. In a moment, we should have this completed. Typically, it takes 2 to 3 minutes. There you go. And it figured out bunch of issues as well. See, this is a warning. This is a warning. How can we read it? We can read it through the HTML file that is generated. Now here, we should have a Zap report HTML document. You can read it from your browser as well. Just do pwd. So this is the location. I'll copy this. I can access it from my browser. File, colon, / followed by the path, followed by zap reports.html. There you go. Tada. So here we have the report and spend some time reading it. I can go through some of them, but if you want to read it carefully, there are medium-sized vulnerabilities, there are critical vulnerabilities, and there are low vulnerabilities as well. Let's see what are the medium vulnerabilities. I'll go through one of them for you. So it says cross-domain misconfiguration. So there is CORS issue on the application. And here it says CSP header not set. This is one vulnerability on the app. This is another vulnerability on the app. And in fact, it is also providing us the location. For example, it says within your JuShop application, there are node modules and there is Express node module. Within the Express node module, there is an issue. Here it says dangerous Java function is being used. I mean a JavaScript function, dangerous JavaScript version. That means a vulnerable JavaScript function is being used. And it also tells you exact function in the code. If you don't trust OWASP Zap, you can actually verify it. Copy this function, go to the source code. This is the source code. Take this in an editor. So I clicked on dot. It opened web editor for me. I'm not cloning the repo again. And here in the search button, I pasted bypass security trust HTML, which Zap report shared. And you can see in different places, in fact, this particular function is being used. Look how cool it is. It does not have your source code, but still from the runtime application, it detected that these are vulnerabilities in your application. And it also gave you exact line number. It gave you the function name and it also gave you the line numbers. So that is why DAST is very, very powerful. You can give DAST tools n number of websites in your organization and let it run. Let it run in the background. It will do the job for you. Especially OWASP Zap is also open source. There is no limit. It will make hundreds, thousands of API calls. And after 20 minutes, 30 minutes, you will get detailed HTML report. Share it with your management, share it with your developers, and let them figure out how to fix the issues. Now, okay, we learned this through CLI. Let's do the exact same thing through the UI. Okay. So what we'll do now? We will run OWASP Zap through the user interface. Again, very simple. Just run this Docker command. This command is also in our MD file. Docker run -it. I'm not really sure from where these lines are coming up. Let me just fix it. So this time we are just running the Zap proxy so that we can connect from the user interface. There you go. Now it says proxy is running. You can access it on port 8080. Let's do that. Localhost port 8080 followed by /zap. Starting the application. So now we can access it from the browser as well. But this will take some time. For the first time, just say, no, I don't want to persist the session and start. You can just expand this utility, manage ads, close it, expand this utility because this is the one we are going to work with. Okay. And this is actually slow. That's why I initially showed you with CLI. Now what you have to do here, click on automated scan and here provide the URL. What URL will you provide? Provide the same URL, that is host.docker.com followed by :3000, which we gave in the CLI as well. HTTP, I'll paste it here for you. HTTP host.docker.internal :3000 and click on the attack. If modern with Firefox, I'm using the Firefox browser and I clicked on the attack button. There you go. You can see here it started making the HTTP requests. In fact, here it is showing you the HTTP request as well. It made GET request on the juice shop build routes and it is making several other HTTP requests. And just like the CLI, this one also will take time for you. And once you have this done, you can get the report from the user interface and you can verify the report. One thing, the report will be exactly the same because whether you do it from the UI or CLI, it does not change. This is cool for your proof of concept, maybe better than CLI. But when you do it through the CI/CD pipelines, definitely CLI part is better. When we integrate this entire workflow with GitHub Actions or Bitbucket, all that we have to do is provide the Docker CLI command and OWASP Zap will be executed. But if you do from the user interface, it is difficult to integrate in the CI/CD. Perfect. So this is all we have for today's video. This will be done in next 10 to 15 minutes. In the meanwhile, you can go through the revision material in our GitHub repository. So we learned about SAST, we learned about SCA, and we learned about DAST. SAST is for static testing. SCA is basically for dependency check, and DAST is for testing your application in runtime. If you have any specific questions, do let me know in the comment section. And please share this video with every DevSecOps enthusiast that you know. And trust me, this is very, very cool. A lot of people might not be aware of OWASP Zap and running open source DAST tool. So if you're interested, you can publish this to your LinkedIn. You can share it with your network and help others also learn. See you all in the next video. Take care.